Alright, since I put up the video on the Browning 180 amps yesterday, just showing the different versions of the amps, I got a lot of questions about well, what tubes are in it, and how much power they do, and how do they work, and all that kind of stuff. So I think I may have done a video on these already, but I'm just going to do another one on the ins and outs of this the 180 Browning business band amplifiers. Pretty simple. On the front, you just got a AC power on light, a rotary switch with off, standby in the middle, and then on the right. You got an output power indicator light that when you have output power, it lights up, and the more power you have out, the brighter it lights. So you can actually use that to tune up the amplifier if you don't have a watt meter. Of course, a watt meter is a better or more accurate indicator of it. And you got your standard tune and load for the Tank Pi network output on the amplifier. And over here inside, you got two tubes, two power tubes, and originally it uses 6 JG6 tubes. There are a few more in that family that are direct replacements, the 6JR6, 6JT6, and then there's a 6KV6, which is a heavier tube, is rated for more watts. You might can push it a little harder with the 6KV6s, but I would not, because that little power transformer there is probably only rated for 100 watts or so, and not 100 watts out, but 100 watts total. And when you key down an amp, the tubes are only putting out about 50% of what goes into them. They're only about 50% efficient. So you put 100 watts into a tube, it's only going to get 50 watts out. So therefore, transformers rated at 100 watts, 50 watts out, that's about the max it'll do. You push it harder, or you put the 6KV6 tubes in and push them harder, you're going to probably blow the transformer. And on these, I've seen a lot of blown transformers. That tube there is a relay keying tube. It has nothing to do with the power output. It's not a driver tube. It keys the relay only. That's all it does. This one is a 6BQ5, and a few of these same amps I've seen 6AQ5s. But either way, that tube is what keys the relay. It doesn't have a transistorized keying circuit. Back in the 60s, when this amp was made, transistors weren't that popular yet, and they used tubes for everything, and hence they used that tube to key the relay, and that's its only and sole purpose. And over here you got your tune and load, and on this side you got your relay, and that's the input matching tuner or input matching circuit. And I'm not going to turn that over since it's live, but I got this one here, and that's basically the inside, the filter caps, a little bit of bleeders, not much. Your light at the bottom, light at the top, and this one had 2 switches instead of the rotary switches. This is the earlier 100. That cap there is the delay cap for the relay. This one is a compromise because it doesn't have an AM or SSB, so it's got a fast delay, which is a compromise. It's a little bit slow for AM, but it's a little bit fast for SSB, so it's not perfect for either one, but it's got a little bit of delay in it. And again, that's the bottom of the relay keying tube, and your fuse and the bottom of that transformer. And that's about all to these guys. On this one here, that cap on top of the relay is the relay delay cap. It's just mounted there. instead of underneath like it is on that one. So that's kind of the ins and outs on it. And I'm going to key it down and see the input SWR there is 2.3. I love these automatic SWR calibrating watt meters. I unkeyed right quick. No calibrating, you just key down and it shows you, you know, what you're doing. And if you notice over here, it's doing just under 30 watts. I need another hand holding the camera. Got the mic keyed down. But anyway, I'm going to try to adjust this input cap, because this one has a knob on it. I don't think that's factory, but since it has it, I didn't do it. But I like it since it has it. I'm going to adjust the input SWR there. Going down, or yeah, SWR going down. Notice the watts going up with the lower SWR. That's because more watts are actually reaching the tubes instead of being reflected back. So that's as good as it's gonna get, is 1.5, 1.4 there. That's it. Can't get it down to a perfect, but that's not too bad for an input SWR. And if you notice, the watts went up from under 30 to under 50 just from adjusting the input SWR. So again, it's a cleaner signal and the watts are reaching the tubes instead of being reflected and creating harmonics that way. Back up to 1.5. So I wanted to show that. And that's the output light. I'm gonna untune it and show you how that you can tune it up and down and go by the brightness of the light, and you can see the watt meter. I'm doing the same thing. So not a bad little, I guess, poor man's watt meter there. One thing about tuning and loading amps, I've had some people say that, oh, I tuned mine down, you know, I'm going to make them last a long time. Detuning or untuning an amp, no matter how you do it, because I've heard some people, well, I do it with the load. I uncouple it, you know, with the load, or overcouple, I guess is the word, not uncouple. Overcouple using the load, and I tune mine down that way. Doesn't matter. Anytime you untune an amp, just like when I tune the input SWR, these tuning loads are for the output. And if you untune it, like tune it so it's not putting out the maximum, them tubes are still eating the watts. All you're doing is killing the efficiency. Remember I was talking about the transformer is 100 watts, but the tubes, you know, are let's say getting fed those 100 watts. So, and they're putting 50 watts out. You got 100 watts in coming from the power supply, transformer, and all that, you know, with the drive. And you're putting 50 watts out with it tuned to the maximum. That means the tubes are at 50% efficiency, and 50 watts are going out, and 50 watts are getting ate or being, you know, turned internally into heat. Just tubes are not 100% efficient. Same with transistors. If the watts aren't going out, and it's got the voltage and the amperage, which are, you know, combined what makes watts. If they're not going out, then the transistors or the tubes, whichever one you're running, are eating those. They're going up in the tubes in plate dissipation. And that's one of the worst things you can do for a tube is overdo the plate dissipation of the tubes. These tubes are rated at about 25 watts a piece, hence two of them 50 watts. So with the 100 watts going in and 50 watts out, that's pretty much their maximum right there. But what happens is, like now we got it tuned up for 45 out, and we're not driving it very hard either, so it's probably not up to that 100 watt level I was talking about. But just for, you know, average sake, we're putting 100 watts into it. Let's say we're getting 50 watts out. But if I detune it, even losing the load to undercouple it, and I tune it down to, let's say, 20 watts, that means that the tubes are still eating or have that 100 watts going into them. Now only got 20 watts going out. That means the tubes are now eating 80 watts. 80 watts are going into the plate, dissipation, going up in heat. So those tubes are frying when I do that, when I tune it down. So no matter how I do it, some people say I'll overcouple it, or using the load. Doesn't matter how you do it. I know about overcoupling. That's for cleaning up the signal a little bit on your modulation. You overcouple maybe a couple percent. Like if you're doing 50 watts, tune it down to 48, overcoupling it. And another thing about overcoupling is you got to know which way is overcoupling for the load. You overcouple the load and you tune it to less capacitance. But let's go on this side of this thing. And you got to know which way is less and which way is more if you're going to try to overcouple. And again, only do it a couple percent. And I bet most people don't even know, without opening the amp and looking at it, which way is less when you turn it and which way is more. Because some caps, less will be to the right, and some other ones, less will be to the left. So you don't know unless you actually look at it. And on this one, I'm turning it clockwise or to the right now. And you can see it's not meshing. So that would be less. And that way, where it's all fully meshed, that would be more. So with this one, if I was going to overcouple it, I would turn it clockwise. But most people, when they overcouple, they always think of turning left is overcoupling it, or turning left is less, because, in most of real life, when you go left is less, right is more, but not in this case on this one. It might be on some of them, but that's give or take. So these people that say they overcouple, I bet most of them don't even know which way it would be to overcouple. And when you overcouple, you only want to turn it just a few watts, just a couple percent when you do it, not 50% or 75%. Like I hear these people say, I tune mine down, I save mine. That's the worst thing you could do for a tube. Maybe overdriving is the second thing you can do. That's the worst, to kill the tubes and the amp. Especially a little amp like this, it's going to blow the transformer and the tubes too. You overdrive it and kill it, or you overcouple it, or you tune it down, however you want to put it. So with an amp, you always want to tune it for maximum output. And then if you do want to overcouple and you know which way to go, you just tune it down a couple watts. So it looks like I'm at 45. I'd go down to 42 like that, just a little bit audio, and that helps clean up the audio. This is ground to grid anyway, doesn't do a lot of swing. And I tuned it for dead key. Normally I tune my amps for most maximum swing audio, which I didn't do on this video. But anyway, that's just my thinking on an amp. Tune for max. If you are gonna overcouple, only tune down that load a couple percentage, not much. Anytime you untune an amp, you're gonna smoke them tubes. You're killing the tubes in the amp. And adjust your input SWR for lowest SWR, or if you really want to get real good at it, sometime the most watts you will get will be a little bit higher than the lowest SWR. So sometimes you can find a happy medium then when adjusting the input tuner between watts and lowest SWR. Like, let's say the amp will put out 35 watts at the lowest SWR of 1.1, which this one wouldn't go to. But you turn it to 1.4, you get like 50 watts. In that case, okay, I'd go with that. But most often, to keep it simple, just tune your input SWR if you have one for lowest SWR. It makes a cleaner signal going into the amp. You don't have harmonics going in because you tuned it for the lowest SWR. And then tune it for maximum output. When you tune for maximum output, it's resonant for the frequency you're putting into it. When you overcouple or too much and tune it down, it's not resonant for that frequency that you're putting out. Let's say I was on channel 11, which is 27.085. When I tune for maximum, that tuning load in that circuit is tuned for 27.085. When I tune it down, it's not tuned to that frequency anymore. It's tuned to something else, and that's going to create harmonics, and you know, it's not being resonant, mean it's not going to filter, and the amp's not going to work or sound, you know, the way it's supposed to. So again, I know I've been a little long-winded on this one, didn't mean to be, but I got to going. Tune your amps for maximum output. All right, that's all I got to say on this one. Bye.